This is the continuation of the videos from Geometry Unit 2A review for your test. I am on the back side of your worksheet, which we are now factoring the next couple of problems. I'm only going to do a couple of these, so I'm going to try to do each one of each type. So in this video, it's going to be 10, it's going to be 12, I'm going to skip 13 because it's similar to number 12, and I'll do 14. So when I am looking at factoring, the first thing you always have to say, is there a greatest common factor? So 25, x to the 8th, 15, x to the 5th. There is a greatest common factor. Both the 25 and the 15 are divisible by 5, and they both have a base of x, so I know what x is, and I look for the smaller of the two exponents, which happens to be the 5. So 5x to the 5th is the greatest common factor, which means that's what I want to divide each of these terms by. So when I simplify, that greatest common factor is going to come in front, and then I'm going to be left with whatever happens after I divide. 25 divided by 5 is 5. X to the 8th divided by x to the 5th, I subtract those exponents, I get x to the 3rd. Plus 15 divided by 5 is 3. X to the 5th over x to the 5th cancel away. I'm just left with this. And this is my factored answer for this polynomial. Now in number 12, again, we want to start with the greatest common factor between the 1, the 6, and the 5. There is no greatest common factor. So then we go to how many terms are there. I have 3 terms, makes it a trinomial. If I have a trinomial, I want to identify what my A is, what the B is, and what C is. Now A looks like it's pointing nothing, but we have to remember there is a 1 there. So what we're going to do is we're going to use our factor x's. In this top part, I'm going to do A times C, so 1 times 5, which is 5, and down here I'm going to put 6, my B value. So what I need to do is I need to figure out two numbers that can multiply to the 5 but add to my 6. So I think of some things that multiply to 5. 5 times 1 is the only thing that comes to mind. So the question you have, is 5 times 1 5? Yes. Is 5 plus 1 6? Yes. So because A is 1 and I have my two factors that multiply to 5 and add to 6, I can come down right here and just say x plus 5, x plus 1. And the reason why they're pluses is because they're positive. If they were negative, you would have minuses instead. Number 13 is going to follow pretty much what we did in number 12, so I'm going to let you do that on your own. Now, when we get to number 14, okay, we go through the same thing. Is there a greatest common factor between our coefficients? 1, negative 3, 3, and 9. And this looks like there could be because the 9, the 3, and the 3 are all 3, but the problem is that this 1 up here doesn't have a 3, so I can't actually find the greatest common factor. So then the next question you ask yourself is, how many terms do you have? I have 1, 2, 3, 4 terms. And automatically, if you have 4 terms, you should think about grouping. And when we group, we find the greatest common factor of each of the parentheses. So I'm going to color this one in here in green, and then the other one will be in gray. So greatest common factor between x cubed and negative 3x squared is they both share an x to the 2nd power. So I factor that out. The factored out version comes in front, and then x cubed divided by x squared leaves us with just an x. I take away the x squared here, I'm just left with that minus 3. In the second parentheses, okay, here in the red, I have a 3x minus 9. So I have a 3 that's the same, so I can divide by 3. So it's a positive 3, so I have to put that out here. 3 divided by 3 is just gone. You're left with the x. Negative 9 divided by 3 is negative 3. If this is factored by grouping, we should have two parentheses that are the same, which we do, so x minus 3 first. And then I create a parenthesis with those greatest common factors that I found, x squared plus 3, the terms that were outside the parentheses.